Hello and welcome back to this series on recreating Baldur's Gate 3's camera inside Unreal Engine. In the last episode, we got the basic project structure set up. That included the classes for the controller, the camera, basic input actions, stuff like that. And in this episode, we're going to start trying to flesh out the camera actor itself, adding the camera to the blueprint and kind of setting up some logic. Maybe we'll get the move functionality in now. Let's get stuck in. So the first thing we're going to do is we're going to load up the camera blueprint we made in the last episode. If it comes up like this, you can just hit open full blueprint editor to get your window here. If it comes up with begin play or anything like that, you can just delete it. We might be adding it in later, but for now, let's start fresh. Let's start clean. And I am running a simulation, so let us quickly close that down by hitting that stop button and getting back in. So the first thing we're going to add is not a camera itself, but a spring arm. And the reason why we're going to do this is when you're working with cameras with characters and stuff like that, it's usually good to have a spring arm first, because the spring arm adds extra logic that you don't quite get with the camera, including collision testing. So that means if it collides with a obstacle, it'll move the camera further in so it doesn't clip through it. And as well as that, we've got some camera lag settings here, which is really useful. We're actually going to enable both of those. And although I said the collision testing is useful, we're actually going to turn it off, because in Baldur's Gate 3, what you'll notice is the camera is allowed to clip through the world's geometry, and actually as it does so, it creates a hole in the world that you can view the character through. And that's something we're going to be setting up later on when it comes to materials, but for now we're just going to allow it to clip through things and just not get involved with the environment so much. We are going to do some collision settings later on, but we're going to do that manually ourselves because we need a bit more of bespoke setup. Cool, so we've got the spring arm in. The next thing we're going to do with it still selected is we are going to add a camera. Nice and simple, add the camera and it should attach it to the spring arm. And if you look in the viewport, you might not see it initially because if we zoom out, it's actually over here. You'll notice it's on the end of the spring arm. And it's going to be 300 units away from the starting point, as you can see here with the target arm length. We can adjust that as we want. I might cut that in half and put it at 150 and see how that works. We might be changing that later, but we can compile and save now. And now that we have a camera, we want to have that spawn in whenever we hit play. So if we close that down for the time being, go to Content, and game, open up our player controller class. Again, we want to open the full blueprint editor. And on the begin play node, I'm going to delete tick. What we're going to do is we are going to, spawn in that camera actor. So we can drag out, do spawn actor from class. And we want to choose that class, which we just created, which was the BG3 camera. So whenever the controller gets created, which happens automatically at the start of the game, it's going to spawn in this camera. And we want to save that camera as a variable so we can reference it later on. So we can drag out from the return value and promote to variable. We'll call this camera actor. And where do we want to spawn the camera? We probably want to spawn it in at the same location as the character gets spawned in. So what we can do is we can get the controlled pawn, which is going to be referencing the character because that's what's being controlled by this controller. And drag out again, get actor transform, which contains the location, the rotation, the scale, all that, and we can just plug that straight into the spawn transform. We can compile and save that now. And actually, one thing we're going to do before we do anything else is we're going to drag out from the camera actor and do set view target with blend. So this is going to overwrite any other camera and set this one as the one we are looking through whenever we are playing the game. And the target is self because it is referencing a player controller and this is inside the player controller, so that's all fine. No blend time, we want to leave that at 0 so it just instantly snaps. We don't want any weird blending at the start of the game. Compile and save that. And if we hit play now, you will notice that the camera looks a little different. We still haven't unhooked the movement from the character, so we can still move around and all that. And actually, if we move the mouse around, it's still referencing the rotation of the other camera, so you can see he's kind of running in circles and whatnot. But we can remove that logic now. So if we go back into here, not here actually, content, third person, blueprint, and open up the third person character. First thing we're going to do is just unhook all the logic. Event begin play, and if you wanted, you could just select all and delete, but I'm leaving it in just for reference if we need to later on, because what the begin play event does by default is it gets the controller and adds a mapping context to the enhanced input subsystem. And it adds the default one, which is what we've seen earlier. It had like move, look, and other actions like that. We're just basically, by unhooking that, disabling all that. So if we compile and save that, play now, trying to move around, trying to rotate the character, nothing happens. So that's good. We've got a blank setting to work from now. So let's try and add some logic to our controller for moving the camera. Now that we've got that camera spawned in, what we want to do is we want to add the mapping context we created in the last episode. So what we can do is get the player controller, which should really be referencing itself, and we are going to drag out from that and get the enhanced, Get enhanced input local player subsystem. So this is the subsystem that controls all of your input. And that's what we're going to be adding the mapping context to. So we're going to be saying, basically, get the BG3 camera input mapping asset and start controlling all of those input actions. So we can do add mapping context. And the nice thing about the the enhanced input system is that you can have as many of these mapping contexts on and off at any given time. So you might add logic for, extra attacks or stuff like that, but we're not going to be getting involved with that too much in this tutorial. We are going to select the IMC BG3 camera and leave priority and options blank for now. Compile and save that. And what that means now is we can start adding the input actions that we created earlier, and they'll start actually triggering when we fire those events. So we've got move camera, which is the one we made. And we've got, what other ones? Zoom. We'll just get references to them all here. Rotate camera. There was rotate camera gate. And we'll be fleshing these out in later episodes. But let's get references to them all now. 1, 2, 3, 4, 5. We had IA lock camera to character. And I keep forgetting this last one, don't I? Move, zoom, rotate, rotate gate, select, lock camera to character, and what's the other one? Orthographic camera. So IA switch camera. And that is the actions we're going to be working with. So we can compile and save that. And you can see also that the action value for each of those are what we set them to in the previous episode. So select, for example, only has a bool value, whereas movement has an X and a Y coordinate in a vector 2D. So what we're going to do is we're going to set up the move camera in this episode and flesh the other ones out later on. So the way I'm going to work is I'm going to handle all of the input events in the controller and send that information to the camera. You probably could set up all of these input actions inside the camera itself, but I kind of like keeping them inside the controller for consistency's sake and a bit of extraction, so that we can have like wrapper content that controls any of these actions before sending it to whatever blueprint we want. So we've got those actions now. in the camera blueprint, we're going to come back here, go to the event graph, and we're going to make a new custom event and zoom in a bit. And we're going to call this move camera. And the input is going to take a vector 2D, and we'll just call this action value and make that a vector 2D. Compile and save that. And back in the controller, what we can do now is we can reference that and send the action value from the input action to that function, to that event. So let us grab the camera actor that we created earlier in the variables, get the camera actor, and we're going to convert this to a validated get, basically saying before we get the value of this camera, check if it's actually valid. If it's null, don't do anything, because if we try and execute logic on a null reference, that's going to cause all sorts of headaches. And the nice thing about Blueprint is it will just throw up a warning. If you try to do this in C++ or anything like that, it might crash the engine. So null references are kind of something you want to get into the habit of avoiding as much as possible. So we've got the camera actor, drag out from that, and we can do move camera. Nice and simple, and now we can hook up the action value to the action value of move camera. And that is pretty much that. We are sending the input values from move camera into move camera. And yeah, we can start setting up logic in here now. So what do we want to do? We want to move the camera. So what we're going to do is drag out from that and do set actor location. So the move camera event is going to be happening, basically, it's going to be triggering as you hold down the key. So it's going to be happening almost like a tick event, just repeatedly every frame. So we want to be updating the actor location as we move along. So what we want to do, first of all, is we want to probably get the camera location, get actor location, and we want to be adding a certain value to it as we go along. So we can drag off from that and do add. And I'm going to do this in the bottom one just for clean sake, and drag that to the new location. So as it stands right now, all this is doing is it's going to be setting the actor location to whatever the actor location already is. That's not very useful. Let's start adding the logic for movement. I'm going to drag this out to give us a bit of space. And the first thing we're going to do is drag out from the action value and break the vector 2D into its x and y coordinates. Now these are going to be used for forward and right values respectively, and then negative values for each of these are going to be down and left. So I can't remember which direction these are. Let's take x to be the forward vector. I might be wrong here, but we can adjust it later. We can do get forward vector, and we want to do that on the actor, so get actor forward vector. And same for the right vector, get actor right vector. And this is saying, or this is giving us a vector value that is directional. So whatever direction we are facing will be this value, and whatever vector is perpendicular to our camera's rotation will be the right vector. And what we want to do is we want to multiply the forward vector by the x value. I think we can drag that into this. The nice thing about these operator nodes is that they take in multiple values, or they can do different types of values depending on the action. And we're also going to add a pin here. And if you right click on that node and do to float, single precision is probably fine. You can drag out from that and do promote to variable. We are going to call this camera speed, or movement speed, should we? Yeah, let's do movement speed. So this is going to dictate how fast we move around. And we'll start by setting this to 10 units, maybe. We can adjust that later. But we've got that, and we're going to do the same for the right vector using the y value. So we can do multiply. Oh, I'm dragging this from the wrong one. get that, and then get the Y value, and then get the movement speed. I'm just gonna copy and paste that for cleanliness sake, and reorganize this a little bit. If you double click on a line, you can get those reroute nodes, and they are very nice for cleanliness. And then we've got these two values here. So the amount we are moving forward and the amount we are moving right. And we want to add that to the actor location. So we can get another value there. And we're actually going to move that down one. Drag this to the top one. And like so. And now we are adding that value to the current location. So let's see if that works. If we hit play and hit W, we are moving to the right, which is not ideal. We've got that backwards. So we can quickly fix that by switching this around. So X goes down to here and Y goes to here. And again, for cleanliness sake, I'm going to tidy this up by just rearranging these. And yeah. That should be our movement now. If we hit play again. Awesome. So the camera now moves forward when we hit W, back when we hit S, left when we hit A, and right when we hit D. And camera speed we might adjust later. But yeah, we've got camera movement now. So that's awesome. In the next video, we're going to be exploring or expanding this a bit more to include rotation, if we can get into it, also zooming. And yeah, we're going to flesh this out a bit more. So I will see you in the next episode.